Okay, here are a few questions for permutations and combinations for the revision of A-level Maths S1. I selected a few that these would help you. Now, this is the first question from June 2014, paper 6-3, question number 7. 9 cards are numbered 1, 2, 2, 3, 4, 6, 6, 6, 6. All 9 cards are placed in a line, making a 9-digit number. Find how many different 9-digit numbers can be made in this way if even digits are all together. So part 1, if all the even digits are together, what we will do is we'll have 2, 2, 4, 6, 6, and 6. 1, 2, 3, 4, 5, 6. So we have all the 6 even digits together. So that's going to be 6 factorial. Divided by whatever the numbers are repeating over here, that's 2 factorial for the 2 2's, multiplied by 3 factorial for the 3 3's that we have, multiplied by, now that forms one block. Now we had 9 numbers, so we have used 6. We have 3 more numbers left. That's going to form 3 more blocks. So that's going to form, so in all we are going to have 4 blocks in all. So these 4 blocks can interchange their positions as well. So that's going to be 4 factorial for these 4 blocks. Out of these 4 blocks, we have the remaining numbers. We have 1, 3, and 3. So the 2 3's are repeating. So this will also be divided by 2 factorial. And the answer would be 6 factorial divided by 2 factorial times 3 factorial multiplied by 4 factorial over 2 factorial. That would give you 720. That's the answer to part A. Now part B. If the first and the last digits are both odd, so the first digit being an odd digit, then we'll have numbers over here, and the final one being an odd one. So I'll start, since we have the odd digits we have in the 9 digits are just 1, 3, and 3. So I'll start with 3 and I'll end with 3. So my first digit is 3 and my last digit is 3. That means I have my 7 remaining digits over here, which are 1, 2, 2. I have used the 2 3's. I have 4, 6, 6, and 6. These are my 7 remaining digits. So that's going to be 7 factorial divided by 2 factorial for the 2 2's times 3 factorial for the 3 6's. Or I can have the first block as my first digit being 1, followed by my 7 digits, and my last digit being a 3. My last digit being a 3. So in this case, it's going to be 7 factorial for the center digits, for the middle digits, the 7 digits which are left, which in this case, I have used a 1. So I'll have 2, 2. I've used 1, 3, so I'll have a 3 over here. 4, 6, 6, and 6. 1, 2, 3, 4, 5, 6, 7. That's going to be my 7 digits. Divided by 2 factorial for the 2 2's, multiplied by 3 factorial for the 3 6's. Now, in this case, I'm saying that the first block is going to be occupied by 1 and the last one being occupied by the 3, or it can be the other way around. I can have my first block being occupied by 3 followed by 7 numbers, and the last one being filled by a 1. So that means this, what I've got over here, can be multiplied by 2 because I have 2 options for this. So my final answer would be 7 factorial over 2 factorial multiplied by 3 factorial for the starting with 3, ending with 3, plus 7 factorial divided by 2 factorial times 3 factorial multiplied by 2, because it can start with a 3, end with a 1, or start with a 1 and end with a 3. So these 2 fractions added up would give me a total of 1260 as my final answer. Now part 2. There, three of the 9 cards are chosen and placed in a line. Now, this is really important. Whenever we see a word chosen, we say that this is combination, but this is not the case over here because they are saying three of the 9 cards are chosen and placed in a line. So it's already done for you. You're not selecting them, you're not choosing them. So that's already done for you. So they have already been chosen, 3 out of the 9, and placed in a line. Now, what you have to do is you have to do arrangements for them. So you're doing permutation for them, making a 3-digit number. Find how many different numbers can be made in this way if there are no repeated digits. So part two, I'll just do over here. So part two, if there are no repeated digits and three of the numbers are chosen. So what numbers do we have? We have 1, 2, 2, 3, 3, 4, 1, 2, and 3 sixes. So if what unique numbers do we have? We have 1, 2, 3, 4, 5. We just have 5 unique numbers. So that's 5. And out of how many? We need to select 3. So that's just 5p3. And 5p3 would give you 60. So that's the answer. Now that's part A. Part 2, part B is if the number is between 200 and 300, how many different numbers can be made in this way if the number is between 200 and 300? So that means the number has to start with a 2. So the number is going to start with 2, that's for sure. And then followed by, now I'm going to say it's going to start with a 2. So I've selected 2. And then I'm going to say it's going to have all the different numbers. Okay, I'm not going to repeat the numbers. I'm going to say my first option is going to be, it's going to have all unique numbers. So that's going to be 1, 2, 3, 4, and this is 5. So there's no repeating numbers over here. So no numbers are repeating. So I've selected one number each time. So, and how many options do I have for the 2 boxes? So I have 5. So two has been occupied for the first one. Then I have 1, 2, 1, 2, 3, 4, 5. 5 unique numbers. So that means it can be 1, 2, 3, 4, and 6. These are my remaining 5 numbers for the other 2 boxes. So that's going to be 5p2, which is going to be filled by this. So that's going to give me 20. Now, the other option that I have is that's going to be the first block is going to be filled by 2, followed by now the numbers can repeat. So if the numbers can repeat, so I'm going to have a 3 over here and a 3 over here, or I can, this has to start with a 2, and I can have a 6 over here and a 6 over here. That's all I can have. So that's a 2, a 3, and a 3. That's just going to give me 1. That's 2, 6, and a 6. That's just going to give me 1. Because keeping in mind that there are 2 2s and I just need to select 1. So that's just going to be 2p2. There are 2 3s and I just need to select 1 over here and 1 over here. So that's 1p1 or 2p1, whatever you want to call it. It's not going to be 2p2. It's just going to be 1p1 and 1p1 again. So you're just selecting 1 3 over here, 1 3 over here, 1 6 over here, 1 6 over here. Which one are you selecting really doesn't matter because both of them are the same. It's just the same digit. So it's just going to be 1 times 1 times 1, 1 times 1 times 1 for 2, 6, and 6, for 2, 3, and 3. So you're just going to get 1 over here, 1 over here. And for 5p2, you're going to get 20. So the total answer would be 22. So there are 22 ways of getting this done. Part B. Numbers between 200 to 300, that's 22. So that's the first question done. Now, the second question is this. In a certain hotel, the lock of a door to reach room can be opened by inserting a key card. The key card can be inserted only one way round. The card has a pattern of holes punched on it. The card has four columns, and each column can have either one hole, two holes, three holes, or four holes. So you have four columns over here. One, two, three, four, four columns over here. And each column can have either one hole, two holes, three holes, or four holes punched on each column. Each column has eight different positions for holes. So each column has eight different positions for holes. The diagram illustrates one particular key card with three holes punched on the first column, three in second, one in the third, and two in fourth. So we can see there are three over here, one in the third one, and two in the fourth one. So that's one particular keyhole that we have. There's a pattern shown over here. Show that the number of different ways in which a column could have exactly two holes is 28. So how many holes do we have over here? How many spaces do we have over here? We have 8. So for part 1, we have 8. Out of 8, we can select any. For it says 2, right? Exactly 2. So 8C2. 8C2 is 28. So out of 8, we are selecting any two positions because they're just going to be holes. So we can select any two spaces out of the 8 given spaces. So that's 8C2, so that's 28. Find how many different patterns of holes can be punched in a column. How many patterns of holes can be punched in a column? So the patterns that you can have would be, for the first one, you will have 8C1. There can be one hole, or there can be two holes, 8C2, or there can be 8C3, three holes, or 8C4, four holes out of the 8. This is for the first hole, second hole, third hole, and four holes. So that's just going to give you 162. How many different possible key cards are there? Now, how many possible key cards can you get? So the number of possible key cards that you can get, each of these column has a 162 ways of having holes in them. How many different patterns of holes can be punched in a column? So one column has 162 different patterns. So that's 162 multiplied by 162 in this, multiplied by 162 in this, and 162 in each column. So each column has 162 ways of having holes punched in it of one hole, two hole, three hole, or four hole. So that's going to give you 162 to the power of 4, which is going to give you a huge number, 688747536 as your answer. This was from November 2002, paper 6, question number 4. Now the third one. This is November 2008, question number 4. A builder is planning to build 12 houses along one side of a road. He will build 12 houses in style A. So we can just make the data over here. So we have A, we will have 12 houses for A. He will build two houses in style. Okay, sorry, we'll have not 12, we'll have two houses. Just erase this. Style A has two houses. He will build two houses in style A, two houses in style B, style C, 3 houses, 4 houses in style D, and 1 house in style E. That's 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that gives us a total of 12 houses. Find the number of possible arrangements of these 12 houses. So the possible number of arrangements of these 12 houses would be 12 factorial divided by the repetition of the style of houses. Because if you have two houses which are of A and A, two of B and B, three of C, 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 four of D, 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 and D, and one of E, so they are basically repeating. They are the same type of house. So they are identical houses. So we have 2 factorial for the two A's, 2 factorial for the two B's, 3 factorial for the three C's, and 4 factorial for the four D's. And let's just calculate this. That should give us 12, 2, 2, 3, 4 factorial. And that would give us 8, 3, 1, 600. 831,600. That should be the answer. Part 2. Now, 12 houses, the 12 houses will be in two groups of 6. See the diagram. Find the number of possible arrangements if all the houses in style A and D are in the first group and all the houses in the style B, C, and E are in the second group. Okay, so we have A and D in the first group, so we have A and D in the first group, so that means we have 6 on each group, in each group. So we have 6 factorial divided by A, how many are in A? So we have 2 factorial for A, and D were 4, so we have this by 4 factorial multiplied by 6 factorial for the other group, which is group B. This is the first group and this is the second group. And now for the second group, we have which B, C, and E. B, so that's 2B, 2 for the B's, and C's, 3 for the C's, and there's only one E. So 6 factorial divided by 2 factorial multiplied by 4 factorial multiplied by 6 factorial divided by 2 factorial into 3 factorial. That should give us, let's just see that how much this is giving us. That's giving us 60. So we get this as 60. So this is for the first group AD, and the second one is for the group which has B, C, and E. B, C, and E. Okay, now the last part, part 3. Four of the 12 houses will be selected for a survey. Exactly one house must be in style B, one house in style B, and style B has 2, so 2C1. And exactly one house in style C. Style C has 3, so 3C1. Find the number of ways in which these 4 houses can be selected. Okay, so we are selecting 4. So if we need to select one, it says exactly one house must be selected from style B. So that's B. This is C. So 3 plus 2, that's 5. And out of 12, so we have 7 left. Out of 7, we will have to select 2. So that's 2C1 into 3C1 into 7C2 for the remaining houses. That's going to give you that's going to give you 126. So that should be your answer, 126. June 2009, question number 6, question paper 6, question number 4. A choir consists of 13 S, 12 A. Okay, let's just write this down. So we have 13s, 12a's, 6d's, 7b's, let's say. A group consisting of 10, a group consisting of 10 we need 10s, 9a's, 4t's, and 4b's to be chosen from the choir. In how many different ways can a group be chosen? So if it's, so this has to be C. So this, we just put a C over here. 13C10, 12C9, 64, 7C4. Multiplied, 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 and that should give us the answer. So let's see what the answer is. 13C10, 12C9, 6C4, 7C, 7C4. Okay, so we get this as, oh, that's a huge number. We get this as 3, 3, 0, 3, 3, 1, 2, and 3. So that's the answer to the first part. Now part 2. In how many different ways can the 10 chosen as be arranged in a line? So they already have chosen the 10 people. 10 and can be arranged in a line if 6 tallest stand next to each other. So out of the 10, we have 10 people. Out of the 10, 6 tallest stand next to each other. So let's say these are the 6 who are standing next to each other. So this is going to be 6 factorial for these 6. Now there are 10, so that's going to make one block. And remember, there are 4 remaining. So if there's 6, there has to be 4 remaining. 7, 8, 9, and 10. 7, 8, 9, and 10. So that's going to form one block is for this, second, third, fourth, and fifth. So that's going to form 5 blocks. So that's going to be 6 factorial multiplied by 5 factorial. And that's going to give you 86,400. So that's the answer to part 2. Now part 3. The 4T and the 4 bases in the group stand in a single line. So we have 4 T's and the 4 B's stand next to each other in a straight line. With all the T's next to each other and with all the B's next to each other, in how many possible arrangements are there if 3 of the T's refuse to stand with any of the B's? So 3 are refusing to stand, only 1 is saying yes. So we'll have the 3 T's over here which refuse, and we'll have 1 T which says yes, I am ready to stand with the B's, the 4 B's. So these are the 4 B's. So we have the 3 T's over here. This is the T with a small b over here, which is saying I'm ready to stand with the B's. So for the 4 B's, we'll have 4 factorial. So if you can just, yeah, okay. So for the 3 T's, we'll have 3 factorial. This T, we can't do anything with this because this T doesn't have any option. So that's just going to be 1. It is saying it's going to stand with the B. It has to go with the B's. Now, the 4 B's will have 4 factorial, or we can have the 4 B's first, followed by this TB again, who says I am okay to stand with the B's, followed with the 3 T's who are refusing to stand with the B's. So 4 factorial again for these B's, 1 for this who doesn't have a choice, and 3 T's for these 3 T's. They can interexchange, they can shuffle themselves, 4 factorial, 3 factorial. So it's 3 factorial into 4 factorial, 3 factorial into 4 factorial, plus 4 factorial into 3 factorial, or just multiply this by 2 is the same thing. So you get this answer as 3 factorial into 4 factorial, that's going to give you 144. 144 times 2, that's going to give you 288. So that's 288. Okay, now the next one. The digits of the number 1, 2, if I can see the question here. The digits of the number 1, 2, 2, let's just write this down. 1, 2, 2, 3, 6, 7, and 8 can be arranged to give any different 7-digit numbers. Find how many different 7-digit numbers can be made if there are no restrictions in the order of the digits. If there are no restrictions, that's just going to be 1, 2, 3, 4, 5, 6, 7. 7 factorial divided by, if there are any digits repeating, that's 2 factorial because of the 2 2's. 2 2's are repeating. And that's just going to give us 2520. 2520. Okay, so that just gives us 2520. That's part 1. Part 2, we have the digits 1, 3, 7 in any order are next to each other. So that's 1, 3, 7 are next to each other. So they form a block. Within the block, they can interexchange their positions, so they can change their position. So that's 3 factorial for them. None of them are repeating, so that's divided by nothing. Multiplied by, if there's, these are 3 digits, so that means there are 4 digits remaining because the total 7 digits. Now, this is going to form 1 block, 2, 3, 4, 5 blocks. So this is into 5 factorial. Now we see if there are any digits remain repeating forms remaining. So that's 2, 2. 137 we have used, 137 we have used, so that's 2268. 2268. So out of these, 2 and 2 is repeating. So that's divided by what I was repeating. So that's 3 factorial into 5 factorial divided by 2 factorial. So that should give you 360. Sorry. Now the last part. These 7-digit numbers are even. So the even numbers. So if it's an even number, it has to end with what? It has to end with a 2, 2, 6, and 8. So it can end with a 2, 2, 6, and 8 to form an even number. So it's sorry, 2268. It's an even number. Even number ends with 2268. So let's just make this as a 7 block. So the last digit we can have, let's say it ends with a 2. Okay, let's say it ends with a 2. So we have the whole 6 digits over here, and the last digit is a 2. So this is a 2 right over here. Now I have, what numbers do I have now? I have 1, 2, I have used 1, 2. So I have 3, 6, 7, and 8. None of them are repeating. 1, 2, 3, 4, 5, 6. So that's just 6 factorial divided by nothing. So that's one option I have. The other one I would have is, this is going to end with a 6 or an 8. So for the last one, I have 6 or an 8. I have 2 options in my last block. So that's going to be 2. And over here, I will have, how many numbers will I have? Because I've used only 1 out of 6 and 8. I can use 6 or 8. So I have 2 options, but I'm going to use 1. So I will still have, I will still have 6 numbers remaining over here. 6 numbers remaining over here. And remember, I've only used 6 or 8. So I still have 2 2's over here. 2 2's. So that means this is divided by 2 factorial. So that's going to give me 6 factorial for the first option, which is ending at a 2, plus, then I have 6 factorial divided by 2 factorial, multiplied by 2, because this can end with a 6 or an 8. I have two options. And since it's going to have that, it's going to end with a 6 or an 8. It's going to have 2 in the center. It's going to have two 2's in the center, so that's why it's divided by 2 factorial. So 6 factorial plus 6 factorial divided by 2 factorial multiplied by 2. So that's 2 and 2 cancels out. So it's just 6 factorial plus 6 factorial basically. 6 factorial plus 6 factorial, that's going to give you 8. What is 6 factorial? That's 720. 720 times 2. That's going to give you 141440. That's the answer. Let's just move on to the next one. Okay. A committee of 5 people is to be chosen from 6 men and 4 women. So let's just have this written over here. We have 6 men and 4 women. In how many ways this can be done? If there must be 3 men and 2 women in the committee. 3 men, 63, and 2 women in the committee. So that should be the answer. 63 into 4C2. 63 into 4C2. 63 into 4C2, that would give you 20 plus times 6. So that should give you 120. Now part 2. Part 2 is if there must be more men than women in the committee. More men than women in the committee. So that's going to be 63 into 4C2 we can have, or the other option we can have 6C4 into 4C1, and we can have 60, we can have all of the men and no women, 4C0. So that's just going to give you 186. Yeah, that gives you, I don't know, that's going to give you 186. Part 3. Part 3 is if there must be 3 men and 2 women, and one particular woman refuses to be in the committee with one particular man. Okay. Now, if there must be 3 men and 2 women, and one particular woman refuses to sit in the committee with one particular man. Now, let's suppose this is the particular woman. Let's have a W over here. And that particular woman is selected. So that's 1C1. I'm selecting that particular woman who refuses to sit with the other particular men. So that means that man will not be selected. And that's the particular man. So if that particular woman is selected, that particular man is not selected. Multiplied by, and I still have to select 2 women. So how many women do we have? We have 4. So out of the, I've selected 1 woman. So out of the 3, I have to select 1 more. And since I have selected no men, and I have 6 men, so the remaining of 5 men, out of 5 men, I have to select 3. So that's one option. Plus the other one is that one particular woman is not selected into that particular man is selected because we are not selecting the woman into 3C1, 3C1, or we can have this as 3C2 now. 3C2 because we haven't selected that woman. So we can have 3C2 now into 5C2. 5C2. So this is woman and this is men. This is woman, men, and this is from 3. Yeah, so this is woman and this is men. Woman, men, yeah. Now, plus the last one we're going to have as selecting none of them. So that particular woman is not selected, nor is that particular man selected. None of them are selected. So, so it says if there must be one particular woman refuses to be in the committee with one particular man. So either one of them is there or none of them is there. So that means over here, out of the woman, I'll have to select 3C2 now. And for the men, I'll have to select 5C3. So these are my total options. So that's woman again, and this is man again. And that's going to give me 1, 1, 3, 10, 1, 1, 3, 10, 1, 1, 3, 10. So that's just going to give me 3, 10, 3, 10, 3, 10. So that's 30 plus 30 plus 30. And that gives me 90 as my final answer. Yeah. Because I get 1 over here, I get 1 over here, I get 3 over here, I get 10 over here. I get 1 over here, 1 over here, 3 over here, 10 over here. 1, 1, 3, and 10 over here. So I get 30 in each bracket. So that's 30 plus 30 plus 30 is equal to 90 as my final answer. Now the next one is this one is June 2005, question number 7. A football team consists of 3 players who play in defense position, 3 players who play in midfield position, and in midfield position, and 5 players who play in forward position. 3 players are chosen to collect a gold medal from the team. Find how many ways this can be done if a captain who is a midfield player must be included together with 1 defense and 1 forward player. So A part 1, we have 3 defense players, we have 3 midfield players and 3 defense players and 3 midfield players. Okay, and 5 forward players. If a captain who is a midfielder is selected, so that one C1 is selected for sure. We don't have a choice, and that player is from a midfielder must be included together with 1 defense player. So 3C1 into and 1 forward player. So 5C1. That's 5C1. 1C1, 3C1, 5C1. So that's just going to give us 1 times 3 times 5. That's 15. 15 is the answer for part 1. Part 2, if exactly 1 forward pair must be included together with any other 2. If exactly 1 forward player must be included together with any other 2. So 1 forward pair, how many forward pairs do we have? 5. Out of 5, we have selecting 1 with any other 2. So 3 plus 3, that's 6. 6. Out of the 6, we can select any 2. So that's 5C1 multiplied by 6C2. So that's 5 multiplied by 15. And that's going to give us 5 multiplied by 15, that's 75. Part B. Find how many different arrangements there are of the 9 letters of the word gold medal if there are no restrictions in the order of the letters. So gold medal, 1, 2, it says 9. Okay, so that's 9 factorial. 9 factorial divided by how many are repeating? L, that we have 2 L's. So that's 2 factorial multiplied by 2 D's. So that's 2 D's. Anything else repeating? L, L, D, D, nothing else. So that's 9 factorial divided by 2 factorial times 2 factorial. And that should give you 90,720 as the answer to part 1, B part 1. Now B part 2. If the two letters D come first and the two letters L come last. So it's going to start with the two D's. So it's D and D. So D and D. And we have two L's. So L and L. So there are two D's. So that's 2 factorial divided by 2 factorial for the two D's, and they both are repeating. Two L's. So that's 2 factorial divided by 2 factorial again for the two L's, and they are repeating, multiplied by whatever is in the center. There are 9 letters. So we have used 2 over here, we have used 2 over here. So we are left with 5 over here. So that's 5 factorial. And I think, yeah, so these are the only 2 letters that were repeating. So that's just 5 factorial. So that's 5 factorial. So 2 factorial divided by 2 factorial multiplied by 5 factorial multiplied by 2 upon 2. So that's just, the answer would be just 5 factorial. And that would give you 5 factorial would give you 5 factorial is 120. So that was, so the answer to part B part 2 is 120. 120. Now the last one. This is November 2007, paper 6, question number 3. The 6 digits 4, 5, 6, 7, 7, 7. 4, 5, 6, 7, 7. Sorry. 4, 5, 6, 7, 7, and 7 can be arranged to give many different 6-digit numbers. How many different 6-digit numbers can be made? So that's just going to be 6 factorial upon the 3 7s are repeating. So that's 3 factorial. That's a straightforward question. So that's just 120. Part 2. How many of these 6-digit numbers start with an odd digit, and end with an odd digit? So it has to start with an odd digit and it has to end with an odd digit. So let's suppose it starts with, what odd digits do we have? We have 5, we have 7, 7, and 7. And then we have 5, 7, 7, 7. We just have 4 and 6 left. So it starts with an odd digit, ends with an odd digit. So let's suppose it starts with a 5 and ends with a 7. So we have one option over here and only one option over here, because the 3 7s are the same. So we can have this as 3 factorial divided by 3 factorial. That's the same thing. And only one 5 over here. So that's just this. And how many will be in between if we use one 5 over here and we use one 7 over here? So we will still have 2 7s over here and 4 and 6 over here. So that's going to be 1, 2, 3, 4. So that's going to be 4 factorial in the center with the 2 7s left. So that's going to give you this. And this is when we have this starting with a 5 and ending at a 7. What if this starts with a 7 and ends with a 5, or the other way around? And we have the same numbers 7, 7, and 4, 6 in the center. So basically we multiply this by 2 because we have 2 options for this. Starts with a 5, ends with a 7, starts with a 7, ends with a 5. So we'll have 4 factorial divided by 2 factorial multiplied by 2 for these 2 options. Plus, now the last option that we have, or, is it starts with a 7 and also ends with a 7. And also ends with a 7. So 7 over here and 7 over here. So in this case, we'll have 1 7 in the center, 1 5 in the center, 1 4, and 1 6. We have 4 numbers and all 4 which are not repeating. So in this case, we'll just have 4 factorial over here. So 4 factorial divided by 2 factorial times 2 plus 4 factorial for the last one. for this one. That would just give us 4 factorial. 2 and 2 will cancel out. 4 factorial plus 4 factorial. So that's 4 factorial. 24. So 24 plus 24, that's going to give us 48. So 48 is the final answer. Okay, so that's it. That was the last question. Thank you.